Today I will be demonstrating how to construct a hyatograph using the alternate block method for problem 9.18 out of the 4th edition textbook. This problem statement gives an IDF curve for Boston, Massachusetts, and asks us to make a hyatograph for a storm with a return period of 10 years and a duration of 40 minutes using 9 time intervals. So first step in the problem would to be define all of the given parameters. For our design storm, it will be 10 years. The duration of the storm will be 40 minutes. And we'll have 9 time intervals. So to calculate each time interval, how long each one will be, we take the duration of the storm, divide by the number of intervals to get 4.44 minutes per interval. Now we can convert this to hours for 0.074 hours. And we will be using both of these in this problem. Next, you're going to want to set up a table with all of these given variables: the time in minutes, time in hours, the intensity times the minutes, the rainfall amount per interval, and the intensity of each interval. Since the calculations are the same for each time interval, I've shown sample calculations for n=1 right here. To find the intensity of n=1, you simply plug in your time equal to minutes into the IDF equation given, and you get a value. For n=1, it's 169 millimeters per hour. To get your rainfall amount, you multiply your intensity times your time interval in hours, keeping your units the same, to get your value for a cumulative amount over all the intervals. For n=1, it's 12.51 millimeters. For your rainfall amount, this is specific to each interval given an intensity. So you want to take your value you just calculated, if you're calculating for n=1, minus the value before whatever interval you're observing. So for this one, for n=1, it's 0, so there's no value beforehand, so your rainfall amount for this interval will simply be the same. But you can see the generalized equation here. If you're observing, say, I interval, you'll take interval I, rainfall amount, minus the interval before. And you can see it in the rest of these as we go down. Now, finally, for your intensity per interval, you take your rainfall amount that you just calculated, divided by the time in hours, and you get 169.05 millimeters per hour. And these are the values that you'll plot in your hyatograph. And as you can see here, they're all ranked from time interval 1 being the highest to time interval 9 being the lowest. Now that you have all of your intensities per time interval, you'll want to plot them in a table, and then you can construct your hyatograph. As you can see here, the highest intensity interval goes directly in the middle of all the intervals. And from there, you can go on either side of the middle interval, plotting the rest of your intensities in descending order. And this will give you a hyatograph that looks like shown, with our highest intensity being at interval 5 in the middle, with descending values on either side alternating until we get to our low value. And this is your end product. This is how you construct your alternating block hyatograph.